Everyone, today I'll show you a flowchart to make a PN junction diode. All the fabrication labs in the world use the same flowchart or use the same process to prepare any kind of device. So as lack of space, I have marked it with points, but you have to write it in a flowchart manners, like you have to use boxes one after and then arrow in between them. Okay, but here I'll show you using the points. Remember that every fabrication labs use the same process, so it is used in all over the world. So the first process is to check whether the wafer that we have, that means the silicon wafer that we have, is of p-type or of n-type using the hot probe method. Hot probe method is a very easy process to check whether a wafer is of p-type or n-type. Here we have to use a voltmeter, and if it shows the negative voltage, it is p-type. If it shows a positive voltage, it is of n-type. So here I am not discussing about the hot probe method in brief, but at first we have to use the hot probe method to check whether it is of p-type or n-type. Second process, we have to clean the silicon wafer. After checking whether it is p or n, we have to clean it using the acid process cleaning. Then it will be cleaned, and we have to check whether it is cleaned through different processes. But as it is a flowchart, I am not discussing the whole process here. It is just the points that we have to use in the fabrication labs, or we have to follow the methods in the fabrication labs. First we have to check whether it is of p-type or n-type. Then we have to clean it using the acid process cleaning. Then we have to use the oxidation through the thermal process, and see the silicon wafer has an oxidized layer on this after the oxidation process. After that we have to do masking. In the masking we will get a dark spot in the middle of this. These are alignments. We have to use these symbols in the masking process. So what we have done till now, we have checked it is of p or n. Let's say we have got a p-type wafer, then we have cleaned that, then we have oxidized using thermal process, then we have masked. Then the next process is the photolithography. Here see, this is black and the surrounded side is white. In the photolithography, the opposite will occur. That means the surrounded side will become black and the middle portion will become white. This is photolithography diagram. Masking to photolithography, only the opposite colors. It is like the photography or the negative photography, what we say. The white parts become black, black parts or colorful parts become white. It is the same. In the masking we have got a black portion in the middle and white surrounded. Here the white surrounded in the middle and black portion out surrounded. Then we have used diffusion. In the diffusion process, this masked after photolithography, this middle portion will become of p or n type. As it is of p type, we have used boron nitrate here. Then we have to do contact, like two wires will be connected using the soldering process in the two parts. Then packing and measurement. After making this, we can check if it is correct or not through the measurement, like forward bias and reverse bias measurements, and we have to plot a graph and see whether it is giving the same characteristics. It will give a cutoff voltage of 0.7 volt, as it is a PN junction diode cutoff voltage. So as a summary, we can say at first we have to check using it is of p-type or n-type. Then we have to clean it through acid process cleaning. Then we have to oxidize using thermal process. Then masking through negative photoresist. Then photolithography, diffusion using boron nitrate as it is of p-type. Then contact using soldering process, and after that packing and measurement to check whether we have done it correctly or not. Thank you.